Yep, so before we go ahead with more things, I have almost taught you each and everything about this OSPF, the words like what is designated router, what's backup designated router, what's LSA, what is LSR, LSU, right? What
Yes.
are areas and how the relationships will be made in between the two areas, or in between the in between the routers within the same area. What's ABR, what's ASBR? These are all the things that I have taught you. Along with it, we have some important terms which I have already told you, but there are more. So important terms related with OSPF or related to OSPF. Router ID, I told you, there is one thing which is called as a loopback address. Loopback address. And I told you, yeah, in my previous class what loopback address is, right? And we are using it for, determining the router ID. So I told you there are different ways how we can determine the router ID. Either we can use the router ID with an highest router ID, or we can use the loopback address. So loopback address is basically a logical or virtual interface on a router. It's not physical interface on a router, it's a logical interface on a router. So by default, the router does not have any loopback interfaces, but we can create them very easily. So these interfaces are treated, but when we create them, we are creating them logically, we are creating them virtually. But when you create them, they're not treated as logical things, they're treated as physical interfaces on a router, and we can assign the IP addresses to them. Are you understanding? So they are logical interfaces, virtual interfaces, but when they are very easy to create, but by default routers do not have any loopback interfaces. But when you create them, these interfaces are treated as physical interfaces on a router, and we can assign IP address to them. So how we can assign, or how we can configure the loopback IP addresses in a router, that's the thing which we're going to learn. So how to create, first of all, loopback interfaces and configure, or you can say assign IP addresses to them. That's today's first time what's loopback address and how to configure it. So what you have to do is in the configuration terminal compt, you need to write the command interface and then give simply loopback. And there will be serial numbers. You can take 1, 2, 3, 4, value 5, 6. It's up to you. Suppose interface loopback value 2, that means loopback interface 2. Serial number of the interface is 2, like we do have in fast Ethernet, gigabit Ethernet serial. And here also we have the loopback interface number 2. And then we can assign any IP address to that. IP address, for example, 200.0.0, the highest IP address will be, designated, will be, counted as a designated router, or will play an important role in router's ID. So that's how we can configure the interface loopback address. So this is the way how do we do it. And now practically I'm going to open my or this Cisco packet tracer. I will simply add, these are very small tidbits. I'm not going to do anything more about it, but I will just tell you how to configure simply the loopback addresses. Let it start, it's booting. After that, I can add one particular router and one particular device also. It doesn't matter, but I'm showing you just how to configure loopback address. Yeah, here we go. So the initial configuration we don't need for now. Enable config terminal. So we'll go to interface, then we'll go to loopback, automatically it will come. If you don't know the serial numbers, you can use the help. You can see these are the serial numbers that you can use. And they're going to start from, these are all the loopback interface numbers. If you don't know sometimes what are the loopback serial numbers, interface numbers, you can see it is 0 to this much number. So we can simply use 2 here or 3 here, and that's it. Line protocol interface loopback 3, change its state to up, and then you can assign IP address, for example 200 dot, it depends which IP address you want, .10. It's not going to play the role in communications. It's just going to play the role as a router ID. So you know why we are using router ID to designate or to make a designated router in OSPF network. So this loopback will also play an important role. If you have the highest IP address configured in the loopback interface, so that particular router will be you can say chosen, or you can say that will be called as the designated router. All right, DSR. So that's 0 and hit enter. In the same way, you can take exit from here and into interface loopback. If you have any other loopback address, for example 4, and then you can see 4 loopback addresses up now. You can configure the IP address of that, like 0.11. It overlaps us. So it should not be same as 200 because it overlaps with loopback 3. 201.0.0.10. You can say IP address assigned. That's it. So this is how we assign. So I told you, once again, I'm repeating, it's not going to play any part in the communication like IP addresses are sending packets from one place to another. It's just a router can have the loopback interfaces so that we can be, chosen as the DSR and BDRs. That's the only use of loopback addresses for now, right? Later on, I'll tell you more uses about it. And area border router, I told you. Internal router, I told you. Designated and backup router, I told you, right? So this was about the loopback configuration, and now we'll move to another topic. Give me a minute, not a minute, just give me. All right, so now today's topic is OSPF authentication. Like we had EIGRP authentication, in the same way we have OSPF authentication. Are you here with me? Are you listening?
Yes.
Okay, great. So I told you in EIGRP, why do we need to have the authentication, right?
Yes.
So same is the concept here in OSPF also. So authentication is just going to authenticate the packets, those who are traveling from one place to another place. And even the neighbor relationship will be created based on the authentication packet. So simply, so I can say that OSPF can be configured to authenticate every OSPF message. It's a security that you need to implement in each router. So this is usually why it's used, and why do we use authentication. It's usually done to prevent a rogue, ROGU, a rogue router from injecting false routing information. So same thing, because over here also we take care about, over there it was autonomous system, but here we have area. So any particular router can have the same area, and it can be a rogue, and it can just inject. It can, when a router will be part of our network, that particular router, which is a rogue router, that particular router can inject, that can update a wrong routing information, and other routing routing particular protocols, or routing or routers, you can say, will take that information and it will poison the routing table. That's going to be a problem in the entire network. So in order to prevent these types of attacks, we should implement and configure the OSPF authentication like we did in EIGRP also. So they will inject false routing information and therefore causing a denial of service, which is DOS attack. Denial of service attack. So two types of, in order to implement or configure authentication in OSPF, two types of authentications can be used. First is clear text authentication, where text will be stored in the router in a clear format, and another is MD5 authentication. So MD5 is basically a message digest version 5 authentication, is used. This type of authentication is more secure than the password does not go in clear text over the network. So that you can say this authentication is more secure than the clear text one, because when you authenticate any particular router with clear text authentication, when a message will be sent from one router to another, the password will be sent, or the authentication password will be sent on clear text authentication basis. You know that what's clear text. Clear text is, if the password is del at 123, for example, so it will be sent with the same particular characters, which is del at 123, which is just of no use. We should never use this particular type of authentication. So always we should use MD5 authentication, so that whatever the password we are sending with the messages which we are sending from one router to another in the OSPF, we should always use MD5 authentication, right? So very important note, with OSPF authentication turned on, routers must pause the authentication process before becoming OSPF neighbor. So with OSPF authentication turned on, when you turn on authentication, you can say OSPF authentication, routers must pass the authentication process before becoming OSPF neighbor. So even if you have a network which is not having the authentication implemented, when you implement or configure authentication, the neighbor relationships will be re-established, and those who are having those interfaces which are having the authentication enabled, those routers which are having the features of authentication enabled, you can just automatically, the routers will re-establish the neighbor relationship, and after that the packets will be, the hello packets will be matched. So based on that criteria, the neighbor relationships will be made. So coming OSPF neighbor. So to configure, I'm going to show you the both ways to configure clear text authentication. Following steps are, first we will go through the clear text authentication. the following steps are used or required. First is configure the OSPF password on the interface by using the command IPOSPF OSPF authentication key, for example, password interface command. This is the command you have to use. Secondly, configure the interface to use OSPF Clear Text Authentication by using the command IP OSPF authentication. That's it. So these are the two steps through which we can configure the clear text authentication on an OSPF router. First, we need to go through IP OSPF authentication key, the name of the password, and then IP OSPF. You have to implement or run this command, type this command on the interface, which is going out, not coming in. Okay, out and in, both the ways. So on the interface. So suppose that you have two routers where we can implement it. So you have two routers. I'm just going to take one simple example, and both are connected. Here we have two subnets, 1 and 2, and here we have two subnets, 1 and 2. All right, so both are in area 0. Okay, so both the routers are running OSPF on router 1 and router 2. So our router 1 will go to the interface. Both commands you need to run on the interface. So interface, for example, on this interface, not on these. So authentication always should be implemented on the interface which is sending and receiving the packets, or you can say the transmission. So in R1 router, we have to implement the authentication on this interface, on R2 on this interface. Suppose this is serial 0/011/0/0/0, and this is 0/0/1. So on both these interfaces, we have to configure the authentication. So very, accurately and smoothly we'll go and try to configure this type of authentication. I will just do it on the same particular router or same particular topology. I have one more router here. I have one more switch here and a device here. Are you here with me?
Yes.
Great. So I'll go to physical interface 2T. I will add 1 or 2 ports there. For now, I'm just adding one only. I will turn it on, 2T, and then turn it off and turn it on. That's it. And then I will add a serial cable. That's it. First of all, we need to configure the network. For example, it's 172.16.0.0 oblique 24, not 24, oblique 16 only. And here we have 192.168. Or you can say, if it's a subnet, so we can make use of the subnet last time. So 16.0, second is 30.32.0. So 16.0, 32 will come on, then it's not going to be 16. So it's 172.16.32.0. And here we will have then 0.1. Here we have 32.1. Here we will use another subnet, which is it's 19, so 64. So here 172.16.64.0/19. So here we will have 1 and here we will have 2. That's it. So we'll go and try to configure first of all the IP addresses on all interfaces. So it's no here, enable configure terminal, and we'll go to interface first of all. Interface on this router, which is gigabit Ethernet 0/0, 0/0/0, and IP address 172.16.0.1 with the subnet mask 255.255. On 19, how much it's gonna be? 224, right? Sana is here. Yep, it's gonna be 224. 224.0. No shat. Khalas. Exit from there. Interface. Serial 0/2/0. Then IP address of that will be 64.1. No shat. That's it. No shat. Exit from this interface. So I'll exit and this write the command. All right, and then we'll go to CLI of this particular, and we'll say no here, enable configure terminal. Then we'll go to the interface serial 0/2/1, IP address 172.16.64.2 with the subnet mask 255.255.224.0. No shit. Exit. Interface. We can say first Ethernet 0/1. Sorry. Interface gigabit Ethernet 0/0/0. And IP address is 32.1. 32.1 with the same subnet mask. That's it. Exit. Okay. And then we'll take one more exit and write to store it in the flash. That's it. And now we need to enable the OSPF. So we'll go to config terminal, router OSPF, process ID, for example, 13, and network. Once again, we'll give the first network, which is 172.16.32.0 with wildcard mask 0.0. Was the wildcard mask of this network? It's going to be 31.255. 31.255, and with the area 0. Another network which is 64.0 with the same area. Then we can say router ID is, for example, 3.3.3.3 for this router, which is going to be the designated router. I will exit from here and exit. I will use the command clear IP OSPF process. Yep, so Kalas. That's it. And then that's all about this router. We'll go to this router then. So we'll go to config terminal again. So router OSPF process ID 13, network. Now we have to advertise these two networks. So network this 172.16.0.0/0.0.31 as a wildcard mask with .255 area 0, and network 64.0